everyone, and welcome to this week's episode of Dr. Wright Breaks It Down for You. My name is Jessica, and I'm here with my dad, Dr. Wright. Hey, Dad.
Hi, Jessica.
We got an email request for a topic. Joanne from California asked us, what is electricity?
I was asked the same question about 20 years before in a really, really odd situation. A friend of mine owned some land out in the Ozarks, and he had this problem. He had so many deer on his land, it was really causing some real problems. And I am a bow hunter, and I've never gotten a deer because I can't shoot very well. I know. And so we hooked up, and on a Saturday about 4 in the morning, I met up with the land manager. And, you come into this guy's farm, and the old land manager pulls up in this old beat-up pickup truck. I didn't know what to expect, but here he was, about 70 years old, with a craggy face and hands and coveralls and everything. And I jumped in the passenger seat and threw all my gear in the back. And we bumped along in this old truck, and all you could see was this guy's curled, fingers around the steering wheel, and you could see his wrinkled hands and wrinkled face to the light of the dashboard. And all of a sudden, out of the blue, he goes, I understand you're some kind of chemistry teacher, some kind of science teacher. And I said, yeah, I am. And he goes, well, I got a question for you. I got a question that's bothered me my whole life. And I go, okay, what's your question? He goes, tell me, what's electricity? I mean, really, what is it? And that was so cool because people don't know what it is.
Yeah.
Let me tell you what it is. Everything around us is made of atoms. Atoms are like little building blocks, like little Legos, and they all click together. There's about 110 different kinds of atoms. Some are really big, like gold and lead, heavy. Some are small, like hydrogen and oxygen. It's how these things come together that determines if something's a plastic or something's a liquid, something is a solid or something's a gas. Now, one thing all these atoms have in common is that they have electrons. Now, electrons are very tiny little black specks. I call them black. I'm not sure what color they are, but I picture them like little chocolate sprinkles, like on a donut. And they're all over these atoms. If an atom has lots and lots of these electrons, like sprinkles, they have a negative charge. If they don't have very many electrons, they have a relatively positive charge. And one thing that's really cool about this is you can scrape the electrons off fairly easily. It's really quite amazing. And it's no different than the sprinkles on a donut. You can shake them and you can brush them and the electrons come off.
Huh.
Now, the first guy to find this electron was a Greek guy named Thales, about 600 years before Christ. And what he noticed was, if you get a piece of amber and you rub that amber with a piece of cloth or fur, and then you take that amber and you pass it over the top of some feathers, the feathers will actually rise up off the ground like magic. Now, amber is a kind of rock. You get tree sap from hundreds of years ago or thousands of years ago, and it becomes really hard. And this amber, if you rub it with a piece of cloth or rub it with a piece of fur, it will get this weird ability to make things rise up into the air. And, of course, Thales called it the amber effect. And that was the first sign of what electricity was. So what amber is it's a waxy kind of material that has lots of little micro holes in it, like Swiss cheese. If you took a piece of that big Swiss cheese and rub it in dirt, the dirt would go in the holes. And when you rub fur or cloth over amber, the electrons fall off the atoms and they go in these little holes. And the amber actually holds a negative charge. And so what's happening is you're waving this amber over the table where your feathers or your little pieces of paper. And you can do this with a balloon. Take a balloon, blow a balloon up. And the balloon is made of rubber like plastic, same as the amber. Rub the balloon in your hair and then hold the balloon right over the top of some little pieces of paper. And the paper will rise up the same as it did for Thales back 600 years before Christ. Really cool. So what electricity is a bunch of these little electrons that are forced into one area, like blowing air in a balloon. And because they all have a negative charge, they don't like being together. They don't like being crowded together. And like a balloon full of air, they don't like being together, so they want to push away.
No, that totally makes sense about the idea that there are the haves and the have-nots. There's things that have more electrons than the other ones, and then the electrons will move towards objects that don't have that many electrons.
That's exactly right. And when we make a battery, what we're doing is we're forcing all the electrons into a little box, and they hate it. And you force them inside, and you force them inside, and you hold them there. And when you want to use that electricity, those electrons, you take something that the electrons can jump on, like a frog will jump across a river on lily pads.
Uh-huh.
What electrons that are negative will jump on is positive things. And the most wonderful and beautiful positive thing we have around us is metal. And that's why wires are made of metal. Almost all metals are positive. And so you hook up a piece of metal to a battery, and the electrons will jump across it and zoom. You can do the same kind of thing. Yeah, it's really cool. You can do the same kind of thing on a day when the weather's kind of dry. In your tennis shoes, dragging your tennis shoes across the rug. And as you're dragging your tennis shoes across the rug, you're actually accumulating these electrons. And then you go up to your kid sister, or you go up to a doorknob, and you touch your finger to the doorknob and you see a spark.
Right.
And what you've done is you've built up all the electrons on your body. And then they don't like being all together. They want to be on something bigger like the Earth, okay? Now, if you touch a piece of plastic like a comb or something like that, it's not going to go anywhere. But if you touch a doorknob that's metal, it will jump on the doorknob and it will cause a spark. That's what electricity is. And it's a wonderful thing.
Wow.
Yeah, it's really cool that way.
That's awesome. All right. Well, thanks so much, Dad, for explaining all that to us. Everyone, tune in next week. We will have another delightful podcast up for you all. And yeah, definitely keep the emails coming. Let us know what you'd like us to talk about, and we would love to talk about it. All right. Thanks so much, Dad.
Bye-bye now.